So Python includes several built-in container types such as lists, dictionaries, sets, and tuples, and they're data structures that help us to organize and manipulate our data in a pretty neat way. As the first one, we'll talk about lists. And think as lists as an equivalent or as an approximation of an array. The difference is you don't need to declare the size of this array, so you can resize pretty much the length you want it, and you can also contain elements from different types. And what we mean by this is, let's say we have a list of elements 1, 2, 3 right here as we have it. Then I can simply say, you know what, now my list is going to be something different. It's going to be 1, and then true, and then text. Why not, right? And then we'll go back and say that's the number here again. And if we, if we go there and print it out, that our list keeps the same behavior, just because different from other language, we don't need to have all the same data type here, right? Now, let's take a look on another example. Let's say we have a list formed by 1, 2, 3 right here. And then, as we saw it before, if you use the actual name for the variable of the list, you print it out the entire list. But if you want to go there and print it out a specific number, you have to pass the index. And as a second reminder, if by any chance you want to take a look on the last elements inside that list, you just use the -1 index as we have here, right? So 0, 1, and 2, so 2 is the first element and -1 is the very last element, right? One of the cool things about the Python, since we don't check for types, we can simply change what information we'll have inside our list. So let's say now that the last element, which is 0, 1, and 2 here, is the number 3, as we can see it. I can simply say, well, for now, you'll have a text instead of the actual element there. And if we take a look on our list now, you'll see that it looks a little bit different than 1, 2, 3 as you had it before. Now it's 1, 2, and 4. So we can pretty much substitute without declaring any type. But if you don't want to substitute the value, instead you want to go there and append a new value. Now let's say we are appending the value of true in our list, right? And if we take a look on this list now, you see that it's going to look a little bit different. Now we have all the elements, including the one we just modified. So 1, 2, full, and true, and we have all there. Now, if you want to pop out the last element, you can simply call the function pop here, and let's take a look how our list looks like now. In this case right here, when you use the pop, it pops out the last element, which in this case here is full, right? Also, we already talked about slicing, right, guys? So what is slicing? It's pretty much when we, let's say we have a list here, and the list is numbers. Let's say we have again 1, 2, 3, and 4, and I want to go there and print it out. Let's say all the numbers from beginning until the very last position. Why not? So we are doing slicing, so it's the very first position, so 0, 1, 2, and it stops before the last position, as we have it right here. With a -1, we don't need to know which index is this. We just use -1, and I know it's going to stop all the way here, because this function, this slicing, is exclusive with respect to the last element. So let's add some more cells here. And one thing is important, we just talked about the pop function, right? So what the pop function does for us, again, yes, that's right. We're gonna go there and we're gonna we're going to remove the very last element as we had here. So now it's 1, 2, 3, and now, you know what, let's do this a couple of times. So 1, 2, and 3 again, and it executed already once, so let's just delete this because I ran one extra by mistake. And if we run this here, what is happening? Since we did a lot of pop-ups in our list, each element it's removed one at a time. So after the list is empty, we cannot do the pop anymore simply because we don't have any more elements inside our list. So that's not possible to run, right? Okay, another cool thing that we have some built-in functions for lists is that we can organize our lists the way we want it, which is pretty cool. So let's say we have something like 19, 3 and 1, and then 9, 2 again, and 3, and 42 and 5, right? That's our list right now. And if we print it out the way it is, we pretty much will have the list that we just saw it. Now, one cool thing is we can use the sort function, and this will help us our list and print it out that in another order, right? So if we do this here and we print it out numbers now, what we can see is that our list now it's in an ordered form. One thing that's important about the function sort is that it takes change in place. And what I mean by in place? In place, it means that whatever the object it's calling, it's going to be the one affected. Some functions, they don't do this. You have to send to another variable because it doesn't take place in place. But in the sort, it does. So after we print it out, we see that it's completely ordered. Now, another cool thing we can do it is we can reverse it. So if we say this, the name of our list, and we say numbers in reverse, and we call our variable list again. So this numbers, and we run it, and we see now it's in the opposite order, right? So there are other functions that we can use during our list manipulation. For example, if you want to query some useful information, and if I'm not wrong, we did this already, but it's always good to remember. So let's say I want to check it out. What is the size of numbers? So you can make a query, and what we mean by query is you are taking some specific information out of the list that you have. In this case here, we are interested in the length. So how large is our list? So we have 8 elements, 1, 2, 3, 4, 5, 6, 7, 8, and there you go, we have 8 elements. Cool thing about the length function we should probably be aware is if you try to get a length of an empty list, you will have 0 because an empty list has no elements, right? Also, still talking a little bit about queries that we can do, you can verify, for example, if you have a certain element within a list. So, for example, can we check it out if 0 is in this list right here? Let's see. Well, it's false because it's an empty list, right? But now, if we check it out for a valid information there, and let's check it out to see if 0 is somewhere between this list. And it's going to be true because it is in the very last position, but it would have the same effect if we had 0 in the other parts as well. And the same thing, we kind of do these queries with numeric strings, numeric lists. We can pretty much do this with strings, since they're a list of characters, so they behave pretty much as a list, right? So can we verify if y is in Python? And hopefully we can all see that yes, y is within Python, right? And not necessarily you need to verify that a given element it's in one type of list only. Everything that we worked before, it's still valid. So let's say the first element is Python, it's 2, and then it's a false, and then we have 1, and then it's true back again. So we're going to compare each element from the left here with all the elements on the right side. And this is pretty much what's happening. So in this case right here, 1 exists in our list. So if you look at it, there we have a true. All right. So thank you and happy coding.